Hello guys, welcome back to my channel. My name is Vishal. In this video, let's have a look on the noise texture. Right now, I have got a simple polysphere and then signed with a principled BSDF shader. So to connect the noise texture, I press Shift A and then go to the texture and then choose noise texture. Once that has come, we have two outputs. One is the factor and another one is the color. So I connect the color to the base color and you should be able to see a colorful result on the model. And this looks very light. For the clarity, I would like to switch off the normalize and you should be able to see a very strong color value there. You can also just connect the factor to the base color where you get only the single channel input to the result. So anything can be used here. So normalize button is generally used to normalize the values. Normalize brings down the value of colors between 0 to 1. Most of the times the values go beyond 0 and 1, sometimes negative and sometimes higher value than the 1. So normalize brings them to the prescribed range. I would like to switch off the normalize just to see the result clearly. You can also connect the factor if you wanted and then explore the values here. So noise texture is a simple Perlin noise texture which you see in any 3D application. So this is used to create that rough surfaces like rocks or dirt floors and anything of that sort. So very useful node. So here we got the scale value which controls the size of the texture. Right now the value is 5. As I keep increasing the value, the texture size becomes so small. I mean the frequency of the texture increases. So I'll bring back the texture scale value to 5. That is the scale value. So increase the scale, the textures become small. Now we got the detail. It improves or increases the detail of the texture here. As you could see, when I'm increasing the value, I could see more high frequency details visible there. Generally what happens is you get layers of octaves one upon the other. You got the low frequency wave and the high frequency wave overlaid with each other, and then you get that multiple layers of it. And this is how it should generally look like. So we have the roughness with a value of 0.5. As I reduce the value of this roughness, you should be able to see the value becomes, the result looks pretty soft. And then I increase this, the result becomes more contrast. Roughness generally blends between the details what we have. For the sake of understanding, we can increase the detail and you should be able to see the texture. And then when I increase the roughness, the contrast is higher. And when I decrease the roughness, the contrast becomes lower. The blend value is what really getting affected here. Then we got the Lucanarity. Okay, then you should be able to see the value is 2. When I reduce the value, for the sake of understanding, I connect the factor, and this shows up only one channel. You should be able to see here. I could only see the red, the green, and the blue, right? So here is the red, that's the green, and that's the blue. And I connect the factor, see which channel is visible. So that's the red channel here. Red channel is generally showing up in the factor, which is the value of the channel. Out of 3 channels, only one channel is showing up. Okay. Now I'll increase this value or decrease this value. Lucanarity, the pronunciation looks too tough. Okay. So as I increase this value, I should be able to see the low frequency wave stays same way and high frequency gets multiplied there. So what that actually means is it is actually the value what is there here is the difference between the high octaves and the low octaves. The scale value which is low and the scale value which is high, there's a difference, and that difference get higher, and then which results in higher octaves as we keep increasing this value like that. Okay. So it has also got the distortion, and you should be able to see it gets distorted like that. So I switch the distortion value low. Now let me just compare this Lucanarity value here, which is basically 2, and then detail, I'll put it back to 2. So when I increase that, you should be able to see the detail is adding more tertiary details out of what we have when we increase the Lucanarity value there. Now see the detailing, what's getting added here with this. So I could say there are like 3 layers of control for the textures. So generally what happens is imagine the noise as this wave. So there is another layer of the noise which is basically coming, and there is another layer. So layers of octaves means that. So when there is only, I'm going to reduce the value here. This is the low frequency wave. And as I increase this detail, I'm adding that secondary layer of octaves, which is giving that waves within the wave. I mean, this is black to white, then black, right? So when I increase the details here, then you should be able to see a secondary wave coming in here. That's a second layer, right? And when I keep working with the Lucanarity here, the frequency looks getting affected there, as you could see of that high frequency detail. So just explore and it would be quite easy for you to understand, okay? Play with the values and then try to get a suitable result. So normalize when we off, this is how the texture generally looks like. You can also connect this to the displacement and you get sort of rough surface there, okay? Because you're connecting it to the displacement there. So here in noise texture, you see something unusual, that is basically the drop down here, which says dimensions. So we have 1, 2, 3, and 4 dimensions, 1D, 2D, 3D, and 4D. And generally, if you come from the other 3D softwares, you have only 2 types of textures. One is 2D and another one is 3D. 2D texture coordinates exist in UV space, where 3D texture coordinates exist in the viewport world space. Now, what is this new 1D and the 4D? So we all know we exist in 3-dimensional space, and 4th dimension is time, right? So Blender brought up this 4th dimension here in 4D, which is nothing but the phase animation, what we have in other applications like Maya, Max, etc. So we have phase or offset value, where you get to see the evolution of the texture, just like animating water. So here we got the W attribute added when we have picked 4th dimension. If not, 2D texture is only a 2-dimensional texture projected from one side. It has got the width and the height. It doesn't have the 3rd dimension here. But when you choose a 3D, then you should be able to see it's more behaving like a 3-dimensional texture. So the good thing is in Maya, we have 2D noise separately and 3D noise separately. Here, this noise texture can be converted to 2D noise and 3D noise at the same time, just by changing this texture type. So these 2 textures doesn't have the W here. So if I just choose 4D, then the new attribute comes here, which is W, which is the 4th dimension, time. So if I increase that value, you should be able to see there is sort of evolution of the texture, just like animating water. If I only pick 1D, then one particular value is applied here, and if I animate the value, it starts blinking. Maybe you can connect this one into a light for intensity, and then the light keeps fluctuating like that, okay? As one dimension does not represent the texture, right? So that can be used in that way. If not, the 4D has this W where you can animate it. And as I told, vector normalizes the value between 0 to 1 region. And then we got vector input, where you could able to connect one procedural texture, I mean any texture coordinate to that. Like I can just connect the UV, and then you should be able to see that 2D texture respects the UV space. You got the poles here, and it's laying the texture on the UVs of the model because I've connected that way. So you can explore more on that side, but this is what we have for the noise texture. I hope you like the video. I request you to subscribe my channel, and if you got any questions, let me know in the comment section. Thank you very much.